Hello, everybody. Welcome to my second consecutive live stream of the sun. So I actually did this live because it looks like this is about to flare, and I wanted to, see if I could catch it because I actually missed it yesterday. I signed off my live, and like 5 minutes later, the thing flared. So I am going to hopefully capture it this time. See, the reason I think it's going to flare is like I saw these bright spots just appear. They appeared over the last 5 minutes. Those weren't there before. So this active region is kind of percolating. Something's going on. There's been pressure building up under the sunspots, and maybe it will erupt. So, and if so, we'll capture it. I'm going to kind of keep an eye on my comments this time. Hopefully, I can stay on top of them, answer questions as I go. Cool. Got a bunch of you on here on Instagram. I don't think too many people are on X yet. Happy birthday, Elvia. Oh, great question. What's the graph on the right telling you? That is a histogram. If you're not a photography nerd, what a histogram is it tells you the amount of values in a specific range of light in a visual format. So, like if the graph is really tall on the left side, you know there's a lot of darkness. So this spike right here, that's the blackness of space around the sun. This hump right here is this gray sun. It's like most of this. And then you kind of see it peter off right here, and these little squiggly lines on the end are going to be where it's flaring. And you'll actually see in the histogram those little squiggly lines will actually extend further right when it starts to flare. So the histogram tells me a lot of data about the image, which is really important because I want to be able to make sure that I'm not clipping any data, because if this gets cut off, that means the camera sensor is overwhelmed and can no longer capture more information, which is bad. So keep an eye on the histogram, make sure it doesn't flare. And also, if I'm like, let's say I'm looking at a very high contrast view or inverted view where this looks clipped anyway, the histogram over here is a cue that maybe I'm clipped even beyond what I'm doing with this stretch right here. So hope that answers your question. Does my equipment measure temperature? No, it does not, or at least not this equipment. I have a focuser that measures the temperature because focus needs to change based on the ambient temperature changes. But that's for like deep sky work. With the sun, I don't worry about it. Anyway, it's really fun to watch these because even if it doesn't flare, sometimes what happens is these little bright areas will expand and kind of trace these like cracks in the sun. Really interesting to watch. Not an actual crack, but it's just kind of looks that way. I'm centering on this little spot right here. And I'm going to change my crosshair to be a little bit more out of the way. Could have sworn I had a way to change the angle of this thing. That's okay. Let's park that right there. That's a better spot for it. Hey, Jeff, I am actually streaming on YouTube as well. I'm streaming on X, Facebook, Instagram, and YouTube. I'm Cosmic Background Studios on YouTube. Or at least I think I'm streaming on YouTube. I haven't actually verified it. I'm using StreamYard, and I'm like such a novice with this stream stuff that I assume it works, but it might not be. So I was clicking on the lines just to have this crosshair to tell me when features drift. Because like my telescope's like pretty well tracking, but it's not perfect. And as a result, at this high magnification, the sun will actually start to drift. And since I'm trying to observe the same spot, I really want to keep it as still as possible, and that way the time lapse doesn't have to be adjusted as much to stabilize it, because then the top and bottom of the time lapse will be clipped. So yeah, I'm keeping this crosshair here on a high contrast feature that I can really easily look at, so that every so often I can make little adjustments like this and make sure that it just stays centered. And just in case you're wondering about this stuff, because I feel like I have to repeat this every single time, make sure that you realize this is very safe. Like this isn't going to like exterminate life on Earth or anything if it flares. Coronal mass ejections, like not a big deal. There's so many like fear mongering news articles where they're just trying to get like ad revenue or whatever from people that maybe don't know a lot about the sun's activity. So when you hear, oh, giant flare pointed right at Earth heading for us, it's going to hit us in 2 days, you're like, okay, am I going to die? Like, no, you're not going to die, everything's fine. It's not even going to knock out satellites. Oh no, I think we're getting clouds. You can like barely see. Yeah, I see it right there. See a little bit of that movement. Yeah, those are clouds. Very thin clouds. And I'm going to peek out my office window here and see how it looks. It looks pretty bright and blue out, so I think it's probably just like a passing contrail or something. So it'll probably go away in a second. But anyways, yeah, I hope that helps, guys. You don't worry about these flares. They're not going to do anything other than put on a really cool show for us. If they're powerful enough, they'll spice up their auroral activity, as we saw earlier in the month. And maybe you'll see some at the lower latitudes again. I doubt it will happen, like as far as like aurora reaching that low again. I really doubt it. That was such a rare event. Like we probably won't see that again until like the next solar max or something. But yeah, I could be wrong. I'm not a solar scientist. I'm just a guy that likes doing this stuff. Don't mind me. I'm gonna drink my coffee still. This is really early in the morning for an astronomer, by the way, guys. But the morning is the best time to do this because it gets too hot in Arizona. Like my computer that captures this stuff like literally stops working. It's because it's so hot. Speaking of, let's look at my memory. Got to stay on top of my memory. I don't know if you guys were on the stream last time, but I actually ran out of memory in the middle of the stream, and that was right when the sun started to do interesting stuff. So yeah, we're good on memory. We got a couple hundred gigs left. So this has been bright for a bit, but it hasn't flared yet. So I'm starting to think maybe it's not going to, or at least not right this second, but it might, again soon. We'll see. Honestly, it could do anything. By the way, if you see me like mess around with this histogram over here on the right, like that's how I make things brighter and darker, and I'll invert things. So I really like the inverted look because it makes the sun look super furry. All right, so while I got you here, why don't we have a little anatomy lesson on the sun? First of all, we're looking at the solar chromosphere, which is one of the atmospheric layers of the sun. The sun's broken into three main parts: the photosphere, which is the part that you can see, because it's just so bright. It's like the photosphere is like 1,000 times brighter than the chromosphere, or something like that. It's like just crazy brighter. And then you have the chromosphere, which is like this little atmospheric layer that kind of hugs the the top of the photosphere. And then you have the corona, which is what you see during total solar eclipses. So my telescope is specifically designed for this. You have to like do several layers of filtration to isolate the chromosphere and basically block all but the tiniest sliver of light coming from the photosphere. And then the chromosphere shows up like a silhouette against that photosphere, which is what you're seeing here. And what we're seeing here, like over here on the right, like we have this kind of this big mass here. I'll brighten it so you can see it more clearly. See that thing on the right? That's called a prominence. This thing is like probably as tall as Jupiter. Like it's probably like 80,000 miles wide and maybe hits like, I don't know, 40,000, 30 to 40,000 miles high off the surface of the sun. Call it a surface of the sun, but like, you know what I mean? So that right there is probably like, I don't know, 4 or 5 Earths tall. Like so just give you an idea of the scale here. Like the scale is wild. And then these prominences, when they're seen like from the top down, I guess you could say it, or they're like just visible against the disk of the sun, against as opposed to against the blackness of space. They're called filaments. So when you see these like kind of dark patches here, these dark little streaks and snakes, those are essentially the same thing. You're just seeing them against the disk of the sun. There's actually a really big one just out of frame here on the left. You can like, there we go, I adjusted, and now you can kind of see it. So that up here, the very top, that line is called a filament, and it's the same exact thing as a prominence, just oriented differently from our perspective. And then you have an active region. That's what like all this is. An active region is where the magnetic field kind of gets like tangled up, and to the point where it interferes with the convective processes of the sun. So the photosphere is where that convection happens, and you get like the boiling pot of water effect where material floats to the top, cools, and then floats back down. And when you have this magnetic field yanking on things so strongly, that process is disrupted because the sun is plasma, which of course is very susceptible to magnetic fields. And when that happens, it gets pulled. The material is pulled down unnaturally, even more so than gravity. You get these cool spots on the surface. Those are sunspots. And then of course sometimes that energy releases eventually just does release, and then that's where you get the flares, the coronal mass ejections, etc. And so that's what we're looking at right here. That's why I'm targeting this spot in particular to see if it flares, just because this area is just known for very heightened magnetic field activity. So if it's going to flare, it'll happen right here. So now the scene conditions are getting really bad, by the way, guys. So you see that wiggling that's happening? That is my atmosphere causing that. So it's not the sun moving. um, so unfortunately, that does happen sometimes. And oh god, the clouds. If I had to guess, I would say a plane flew by really close to the sun. And what we're seeing right now is the contrail and the jet wash kind of washing over it. So that's going to probably clear up in a minute or so. But yeah, it does mess with the sun. I could go outside and look, but I really don't want to. It's nice and air conditioned in here. All right, I'll go back to answering some questions since I'm done monologuing. Yeah, somebody asked me if I'm watching this every day. Yes, I have been. When I'm home, I try to do this every single day. I do travel a lot because a lot of the shots I can't get at home. But I yeah, I mean, I've got my solar telescope in my backyard and it's always set up ready to go. So it's really pretty simple to do this. I just kind of pop into my backyard, open up my observatory because I built like this garden shed basically in my backyard, and the roof has a gate opener attached to it. So the roof actually opens up for me, and then the telescope just pops out, and then I can start shooting the sun. And again, that telescope's specifically designed for this. Please don't like point a telescope at the sun because Andrew told you to. That's not what I'm telling you to. Learn how solar photography works if you want to get into this because it's very important to do it safely. If you don't do it safely, you're gonna go blind. But yeah, I've been doing this every day for like this is my sixth day, I believe. Um, Time lapsing this very specific active region. Um, just gonna center this thing again real quick. What are the questions we got? Ooh, really great question here. Would you die if you were on the moon uh, when there was like some kind of coronal mass ejection? So that's actually a concern for long duration lunar missions is they are exposed to additional radiation from the sun, and the radiation does increase when you get those highly charged particles coming after a coronal mass ejection or a flare. Actually, in the movie, or not a movie, in the TV show For All Mankind, it's kind of about this alternate future. I don't know if you've seen the show. It's about this alternate future where if we had set up that lunar base, we were kind of talking about in the 70s, and it's kind of what happens, following that. And one of the major plot points is they have to get to cover because a flare happens. Actually, I think it was a coronal mass ejection, and they are kind of exposed. Um, but yeah, in order to mitigate that, they actually need to have safeguards in place. Now we have a lot of warning when these things happen. Like we knew a couple days in advance all that aurora was going to happen because we saw the CMEs happen. I could see it right now if something like that were to happen because we just see it unfold in front of us. And then you would have 2 days to tell the people that are on the moon, be like, all right, you need to get into your radiation shelter or whatever by this time, because we'll know how fast the particles are moving and we'll be able to protect them. But yeah, if you're caught out alone in your spacesuit, yeah, you'll get all kinds of radiation, probably a deadly dose of radiation. I don't know like the numbers. I'm not a radiation expert or a solar weather expert for that matter, but um, yeah, my understanding is you could really damage yourself, like get cancer and stuff. Like it wouldn't like you wouldn't just drop dead, but you'd probably have a shortened life expectancy. You'd probably have a number of cancers develop. I believe in the show, one character goes blind because of it because they get cancer in their eyes. I don't remember the name for that. But anyways, yeah, really really dangerous stuff. But our magnetic field protects us on Earth, so don't get too much UV exposure. But other than that, these flares don't affect us at all. Um, the changes in our atmosphere affect the UV index. Yeah, if you guys are on my live stream on Instagram, I agree. The stream there is terrible because it's like not formatted for that type of screen. So just know I'm also on X at A James McCarthy. I'm on Facebook at Cosmic Background Studios. Also, that's my YouTube at Cosmic Background Studios. Also, by the way, guys, when you see these lives, you should share them because I'm sure we all have that like conspiracy theorist in your life that's like, oh, all these space pics are all fake and photoshopped. And it's like, well, this is as live as it gets, guys. It's literally the raw feed from my camera. So if you have anybody like that in your life, share this stream and make sure they see it. Not that I'm welcoming conspiracy theorists to these things because they're kind of annoying, but on the other hand, I want to like kind of curb that as much as I can by just simply offering a very unfiltered look at what's happening in real time. And also, those people can ask questions, and I don't know, it's a good way to learn. I like to conquer ignorance with education. But yeah, I agree. Get off Instagram. It's terrible. it's it's funny. It's where my biggest audience is too. But it's just I feel like it's just not really well designed for this. I like X. I think the best just because it's like the best like interactive communication. Like you guys, like the live stream will just be up there now permanently. So it's like if you missed yesterday's live stream, you can go watch it still on X. You can't do that on Instagram. And of course, it's in higher quality. And of course, it's on YouTube too, although I don't know how that works with saving them on YouTube. Uh, yeah. So, by the way, guys, I'm actually still stacking yesterday's observations. Let's see, is it still going here? Yeah. So look at this. I'm 21% of the way through. This is. Let me think. This isn't the time lapse. Actually, this is from. This is from this morning. So this is actually something different. Let me show you what I shot this morning though, because it's actually really cool. So this is on a different part of the sun. We have all of these prominences, and they look like fountains of plasma. This is happening in the opposite limb from where we are right now. So really, really cool. See, that's a filament. We got a little small active region here. This is a giant prominence. I mean, that's like what 150,000 miles long. Just massive. By the way, guys, if you're wondering why this is monochrome, I use a monochrome camera to capture this specifically because of the type of filters I have to use. So, like, it's really hard to get this look at the chromosphere. In order to do it, you have to use like two interference filters and just kind of tune them back and forth until they're just right to get this amount of light through. It's not like very accurate science. It's like it's like kind of weird. Like you almost have to wing it to get it to work. But then on top of those filters, on the camera you use, like if let's say like let's use a camera on a phone for example. The camera on your phone has an ultraviolet and an infrared blocking filter and a Bayer filter. Both those things will actually mess up the signal from this. In fact, if I try to use my cell phone through the eyepiece of this telescope to see it, it wouldn't be able to see what my eyes see because my eyes are actually more sensitive to the infrared than my phone. So those additional filters in a color camera actually screw up that signal. So in order to do that, I have to have the most unfiltered camera possible, which is monochrome. So, and then I just add the color back in when I process. This is the only time I add color to any of my work. Um, Usually, the color in space images comes naturally as a process of channel integration, which is something I can talk about if you want. But yeah, because even false color images, you're not adding color to get false color. It just means that the what's the best way to say this? What the colors you're seeing don't match exactly what it's emitting. So and that's usually done because hydrogen and sulfur emit basically like slightly different color reds, and it overwhelms fainter emissions like oxygen. So you don't want every nebula to just be like all straight red because there's actually much more information in that nebula. So you reassign the hydrogen to green and leave the sulfur as red, and that gives you a much more dynamic image with much more visual information. It's much more useful for scientists, and they're pretty too. I mean, both images are pretty, in my opinion. I think that there's no wrong way to shoot a nebula. I personally like doing the false color route because there's just much more going on in those images. But yeah, in case you're wondering what false color means, but space is very naturally colorful. So through the telescope, if you were to put an eyepiece on this thing instead of the camera, it would actually look a very vivid red. It would look like the most saturated red you've ever seen. Oh, cool. Wait on YouTube. Buying a telescope this month. I love it. It's great. Yeah, if you want to get a telescope, by the way, guys, I have like guides on pretty much every channel I post to. The best one is probably on X at A James McCarthy. Go on my X feed, and you'll see it in my highlights at the bottom. There's like a whole thread there that includes a YouTube video. YouTube video is a little out of date. The thread's a little bit out of date, but it's still pretty good, useful information. Oh, asking about Starlink satellites getting in the way. No, they do not. If I caught a Starlink satellite transiting this, I would actually be really excited because that would be pretty rare. And because of the nature of how I capture these, they will be stacked out anyway. Like they won't even show up in my images. And they would zip through very fast too, by the way. It would probably take about, I don't know, a fifth of a second, actually probably less than that, to go from one end of this image to the other end of the image. So it'll just go zip and then it's gone. Like kind of like what the birds are doing. So yeah, that's Starlink satellites are a non-issue for most astronomers. They have a very bright radio signal, so they can mess with some radio astronomy. But in my opinion, I think getting internet to underdeveloped parts of the world is more important than astronomy. And I know I say that as an astronomer, but that's why I'm willing to give Starlink a pass. They were actually very responsibly designed to and have a very minimal impact on optical astronomy. So I'm on board with Starlink, which surprises a lot of people, but I also use it because it's really nice having connection when I go to remote places to shoot. But Starlink satellites are really easy to spot during blue hour. Like they're pretty much everywhere when you're like right after the sun goes down and you start to see those first stars. Just look around, you'll see little lights moving. Those are Starlink. And then after about an hour of that, they'll all disappear. They're in the shadow of Earth. So, by the way, guys, obviously another cloud went through. Not the best conditions for this. So this isn't going to be the smoothest time lapse I've ever done. Oh, so great question. Is this live footage or previously recorded? This is live. So you want me to move the telescope? I can move the telescope. If you want me to, kind of zoom in on something, I can do that. Um, yeah, it's real time. Unfortunately, the clouds are not making me happy right now. Yeah, it's looking gray outside. It not like the sky's still blue, but like the ground looks gray because there must be a big cloud blocking it. Ah, come on, clear up. At least it's not flaring right now while there's a cloud. That would be a little depressing. Getting a little better. So the sun does revolve on its own axis, by the way. That was a great question from Memes Dealer 64. The sun takes about 27 days to a full rotation. So between that and then the extra, like, I don't know, like maybe 10% that's caused by, it's actually less than 10%, it's like 8%, I think, caused by the Earth rotating around the sun, you get a lot of movement. And you can see that in my time lapse videos that are on the limb. I posted one yesterday. And in that video I posted yesterday, I kind of like cranked up the speed on that. And you can see it looks like it's tilting. The active region I was shooting looks like it's tilting. And that's because it's kind of curving towards us as the sun rotates. So yes, it does rotate on its own axis. Cool, we're back. And look at that. It's nice and stable too. Nice thing. Sometimes clouds actually really do stabilize things, which is nice. I think I was like right here. There we go. Let's go inverted again. I love this view. But should we zoom in a little bit? Let's zoom in. Hey. Not the best conditions. Obviously, the atmosphere's still wiggling, but you can kind of see it come in and out of focus. No, the cloud. The cloud is back. But these little like dark streaks here, these are like the really high energy parts. These were what I was watching at the start of the stream, hoping they would flare. And they didn't, but that's okay. If you're talking about the red lines in the middle of the sun, it's the crosshair that I use to tell me if it's been drifting or not. So they just help me. Earth is round, by the way. I see that question a lot. Earth is definitely round. And actually, one of the ways that I know that for sure is by how my equipment works. In order to make sure that my equipment's like set up correctly to track this, I have to have the angle of like the main axis set according to my latitude. And the latitude is the angle on a sphere. So you think picture a sphere and like the angle of that. So I have to put in my degrees relative to the Earth's axis and make sure it matches. So it's round. Sad that I even have to explain that, but yeah, it's round. And if you really want to know for yourself, you can just go on a commercial flight at 35,000 feet. If it's really clear, sometimes you can see the curve visually. But even if not, what you do is you take your phone, make sure the horizon's dead center, take a photo, and then you compress it really tightly along the horizontal axis, and then you see the curve. So the curve is detectable from that altitude, just not very obvious visually unless you're like really in tune to it. Great question from Raquel. Is Earth a perfect sphere? No, it's not. It is actually an oblate spheroid, but it's close enough to a sphere that you can call it a sphere. It's closer to a sphere than a billiard ball, is what's been kind of said a lot. It's because yeah, it has mountains. Yeah, it's a little bit oblate along the equator, but it's still so close to round. It would function perfectly as a billiard ball. Actually, better than an existing billiard ball. Um, so do the spots move in a specific direction, such as east to west? So the spots actually don't really move at all. What happens is the sun rotates. So this image is actually flipped. Um, but so like this object right here is actually on the left side of the sun, not the right side of the sun. And it is moving from left to right in reality. On my video, it would be moving from right to left because it's flipped. But that is not because the sunspot's moving, but because the sun is rotating. But yeah, so they all move in kind of the same direction because of the rotation of the sun. Dustin, you're asking about a masterclass for fellow amateur solar photographers. I don't offer anything like that. It's not really the type of thing I have any interest in doing, mainly because I feel like my time is better spent doing this kind of thing. Like doing a live or even just posting my images online. Like I can reach like thousands and sometimes even millions of people, and kind of spark that interest in this stuff where the motivated people will actually just go out and learn on their own. Um, I used to do one-on-one coaching, and what I found was one, I'm not the best teacher. I don't think I necessarily just have the patience for it, or I don't know, I'm missing something. And also, it was like really depressing to me because a lot of these people that I would be coaching would spend a lot of money and a lot of time on this equipment, and then they would fail because it's hard. It's nothing against them for failing. Like this is like one of the hardest hobbies. And it was just kind of depressing seeing that happen just a lot. There wasn't a lot of personal gratification in it for me. The ones that really persevered, it was amazing. And they go on to do great things. One of my favorite people I coached was journalist Johnny Harris. You guys might know of his videos. He does a lot of videos on like international politics and wars and stuff. He did a really great YouTube video called, I think it was called like The Thing That Nearly Ended Me or something like that. But he worked with me to try to figure out how he could take a photo of a galaxy himself. And he really well documented the entire journey, the selecting of the equipment, the chatting with me to like kind of get things moving, kind of what it takes the long hours at night, kind of dealing with equipment that was maybe not working very well. And he ends up getting the shot. And it was a great shot. He did fantastic. Definitely one of the better people I've worked with as far as learning this. But that guy poured so much of himself into it for like months and got one photo eventually after a lot of struggles. And that really summarizes kind of what the barrier for entry into astrophotography is. It's not the cost of equipment, although that is barrier of entry for a lot of people. Um, it's not the accessibility of dark skies. It's not clouds. It's really just your own perseverance. Um, your own perseverance, because there's people that do astrophotography in some of the cloudiest countries with the lowest budgets, and they're still able to do it. So yeah, it's just do you love it enough to do it when it's hard? Is what I say kind of gets people to succeed. I think the reason I'm doing this at a level that most people don't make it to is because I loved it enough to do it when it was challenging and frustrating. And not everybody's like that. So just know yourself and don't take on challenges that you're not going to have the energy to see through. Hey Kim, you're asking about the planet parade. So guys, you've probably seen a lot of news articles about this upcoming planet parade. That's where like the planets are kind of lined up in the sky. Um, just take it from me, this is a very lame event. I kind of hate how hyped it is because so right now at sunrise, there's only going to be two planets visible, not a parade of planets visible, but two planets visible. It's Saturn and Mars. Mars will look like a teeny tiny red star, and Saturn will look like a regular star. So if you don't know exactly what you're looking at, you wouldn't know anything was happening at all. And the moon will be there. There'll be a crescent moon. It's like the morning of the third, I think. The crescent moon is just kind of situated between them. So Venus isn't visible. Jupiter isn't visible. Those are the two brightest planets. So the planets that are the most interesting to look at just visually aren't even there. So again, it's just a very lame event. I hate how hyped it is because I feel like there's pressure on me to get a really cool shot of it. And I'm like, the only way I can get like a really good shot of it is literally if I just like photoshopped in a bunch of planets like close together, like they're doing in these like the cartoons of the event that they'll share, like the renders. And I'm like, I really don't like doing that. I did that last year, and it's like so many people are like, wow, they were this close together in the sky. I'm like, no, it's like a composite. It's kind of artsy, and I just hate contributing to that type of misconceptions about things. Even though it's kind of a harmless misconception, it still isn't the type of person I want to be. So I try to avoid doing that. But anyways, yeah, it's kind of a lame event. So sorry. I wouldn't. I'm gonna be sleeping. I'm not gonna bother. I might get a photo of the moon or something, but like, why bother? So I'm getting a lot of comments, so I'm trying to go through them as fast as I can. But yeah, if you don't mind, share my live streams, whatever platform you're on. That way we can get more people to ask good questions. Uh, Seal asked a great question. If the polarity of the sun changes every 11 years, which kind of leads to the solar maximum and all this stuff, does the rotation also change? The answer to that is no. It does not change. The polarity shift does not affect the rotation, because the rotation. Just think about how much energy it takes to get something big spinning. Like it'd be like if you were to stop the sun and like spin it the other direction, it would be chaos. Like I don't know what would happen, but I imagine it would not be good for us on Earth. But yeah, no, the sun will always continue moving in the same direction it has for billions of years, which is really just the maintained angular velocity it had from the formation of the solar system. You get a big cloud as it coalesces. You guys familiar with conservation of angular momentum, which is kind of like when that you have an ice skater doing twirls and they pull their arms in and then they start twirling faster. It's the same thing with planets and star formation that leads them spinning. And then once they get spinning, there's nothing to slow them down, so they just spin forever. Planets can get slowed down by the tidal forces of the sun's gravity dragging on it, but that's how you get tidally locked planets. But that's a little different. The sun does not have anything that's going to cause it to stop spinning. Oh, great question. Is this an Earth-based telescope? Yes, it is. It's in my backyard. It's like 200 feet away from me, like over there. It's just sitting in there in like this little garden shed that I built, and the roof opens and the scope is pointed at the sun. So it's a pretty small scope. It's like 5 inches in diameter. So like the opening of the scope is like that. It's not as big as you'd think. Um, and obviously it gets pretty decent views. So it just kind of shows you the accessibility of this type of photography. The scope itself, I think, was like $700 now. I don't know what it costs now, but I think I paid like $600 or $700 for it when I bought it. And then, of course, you have to buy the filters for it too. That's even more expensive. So um, and then you have to put it on a mount, which adds more cost. So I would say you need to spend a few grand if you're going to get into this type of photography. There's cheaper ways to get into it. You can buy a Coronado PST for like $600-700. You can actually find them used for like $500 from time to time, and that'll show you the chromosphere like I'm looking at here. So somebody's asking, what magnification is your telescope? The magnification actually doesn't, like you think of like 300x or 1000x or whatever. That actually doesn't apply to photography because you're dealing with a fixed field of view. So that's why with photography they talk about focal length, not magnification. So the focal length of this is about 3,650 millimeters. So you can go Google that or whatever, like kind of get a feel for how zoomed in that is. But at that focal length, I'm also using a very cropped camera sensor. It's a very small camera sensor that I've actually cropped down even further to get these views. Um, So it's very highly magnified, but I don't know like an actual like number because first of all that's math and I'm not a fan of math. But it also doesn't. It's not really a appropriate way to measure something when you're photographing it. Oh, Jeff's asking what my Twitter handle is. I'm having a hard time finding you. It's A James McCarthy at A James. That's my middle name, McCarthy. I'm sure if you just type in Andrew McCarthy, you'll probably find me because that's my name. Um, oh, thanks, Mikey. Mikey typed it out. This is on Instagram. Thank you, Mikey. Oh, cool. You were staring at the sun with the eclipse glasses and saw the sunspots. Nice. I was able to see this same sunspot we're looking at right now. Like I don't remember when it was, like 2 weeks ago, 3 weeks ago, when it was like still facing Earth. And I could see it like not naked eye, but with no magnification, just with my eclipse glasses. I just looked up and there it was. This one I don't think you can see unless you have like the craziest good vision. But there's actually another one on the sun right now that's on the other side that's even bigger than this right now. It's not quite as active, but it's really cool. And you might be able to see that one. I haven't tried, but maybe I should go grab some eclipse glasses and go look. Yes, I am the guy who captures pictures of the moon. Yes. I mean, a lot of people capture the picture of the moon, but that's kind of what I was known for a very long time was just moon pictures. I actually haven't photographed the moon very much at all. I mean, I took a picture of the flower moon, but I haven't done a good moon photo in a while. And honestly, maybe it's time. Maybe it's time to get out there and do like some insane moon photo. I love taking photos of the moon. I find it very like cathartic. I just kind of sit there with my wait for the conditions to be good and capture those photos. And there's something about the moon because it's never changing. So it's like there's this familiarity with it to me, where it's like as I'm slewing across the surface, I'm recognizing features. And oh, Copernicus, you look nice today. Or Starchus, wow, look at you. And it's like revisiting an old friend every time I go there. But the moon is like the easiest thing to photograph, but you can also make it very hard. Oh, we got a piece that's brightening right here, right in here. I'm gonna move this crosshair. Look right there where that crosshair is. That part right there is getting brighter. So maybe we'll see a flare. Come on. I feel like that meme where the guy is poking something with a stick and he's like, "Come on, do something." That's literally me right now. Have I ever photographed the moon in the southern hemisphere? No, I have not. I've only been to the southern hemisphere one time, and I did not photograph the moon while I was there. It was before I got into this. All right, so you're asking what filter do I use my telescope to be able to see this? So what I use is, I'll try to explain this to you really easily. First of all, it's not an aperture filter. The cheapest way to do this is like to spend $20, $30 and you buy something called an aperture filter. It's basically a neutral density filter that goes on the objective end of your lens. They're usually like silvery material. And what it does is it cuts down like a huge percent of light, like 99.99 something percent of light. And as a result, you see the solar photosphere. But I actually need to filter out the photosphere to see this because this is the chromosphere, not the photosphere. The photosphere is so much brighter than the chromosphere that a neutral density filter will never show you this view. So you have to isolate the emission line of the chromosphere and only allow that to pass through and not like a sliver more because then it's too bright and you can't see it. So what I use is something called an ERF or an energy rejection filter. that goes inside the telescope. And what that does is that gets rid of all the extra ultraviolet and infrared light that I don't want. So that helps keep the telescope from overheating. Next, I have something called a Daystar Quark chromosphere. And what that is it's got this etalon inside it, which is basically two heat-tuned hydrogen alpha filters and a blocking filter. Um, and on top of that, it also magnifies it by like 4.1x or something. So it's able to get down to a very close focal length, but it also cuts the wavelength of light down to like a half angstrom wide. So all you're seeing is this chromosphere through it. And I've done a couple other modifications since then. Nothing crazy you need to worry about, but just to like get the image just like that much tighter and that much better. And then, of course, you need a good camera for this. I use the Player One Apollo M Max. That's what I'm using right now. Another good one for this is the ASI 174mm, but it's a little bit out of date now. That's what I used to use. I recently changed to the Apollo M Max. It works a little bit better. It's a monochrome camera because you do not want to add filtration to something that's so precisely tuned. And color cameras get color by filtering the light. They have an internal filter called a Bayer filter that allows them to see in color. So by foregoing that, I can capture these details. So yeah, it's kind of a lot to it. You're not going to remember everything I just told you. So what I would recommend is actually just like going to a solar forum. Like Cloudy Nights always has people talking about this. Go to cloudynights.com and there's tons of people talking about shooting the sun, what they use, and but a good way to get into this just as an entry level is just buy like a Coronado PST or like a Lunt 40 or one of those solar telescopes. Oh, that's so many people. That's so funny how many people heard of me because of that Distractable podcast. I'm assuming it's the Distractable podcast you're talking about, where Markiplier declared his undying hatred for me. I'm assuming it was a bit, because who could hate the moon? God. Oh, what software am I currently using? This is SharpCap. It's specifically designed to allow your computer to read the astronomy camera. Most cameras have all the internal software you need. They have their own screen, they have everything, so you don't need a computer for them. My astronomy cameras are literally just a sensor with like a feed into the camera. Like they have like a USB port and like a camera sensor, and then like obviously the internal hardware, like memory buffers and things, so that the camera works. But there's no like screen on the back of it. It does like no processing whatsoever. It literally only outputs the raw video or raw photos. Um, kind of streams like a video, but it's photos. Adriana, this is a hydrogen alpha filter. This is a hydrogen alpha filter. It's just a very precisely tuned hydrogen alpha filter. But yeah, this is only visible in hydrogen alpha light, or at least, I mean, you could see it in ultraviolet too if you're in space, but we're not in space. Um, there's a few different types of solar etalons. There's calcium K, which is like a special bandpass that's close to ultraviolet. And you can see some of these prominences with it, but otherwise it doesn't interest me as much. You don't see like this fur. This fur is only visible in the hydrogen alpha light. Oh, it's still kind of bright right here, but it's not really popping off or anything. So maybe the sun's just had a little fart or something. But I don't know. What are your thoughts on these streams, guys? Should I do more of these? Like when the sun doesn't do something, I'm like, it's kind of boring. Maybe nobody wants to see this, but If you guys are interested, obviously I have no problem talking for hours, but it feels weird just because it's almost like I'm talking to myself. It's not like I'm doing a podcast or something and going back and forth. It's just literally me rambling for hours. And if you just got here, by the way, guys, this is an active region on the sun. It's the same active region that produced all those aurora a few weeks ago. I'm watching it in case it flares again. So I want to catch it if it flares. I'm um, I'm checking notifications to see if anybody's told me about anything crazy happening that I can change the camera to. My friend Simon was texting me saying that he thinks this filament is actually going to lift off soon. That's this one over here. If that happens, I'll change the field of view and we can watch it lift off. Because these things, also filaments, again, if you missed my spiel earlier, filaments are the same thing as prominences. They're just masses of plasma caught in magnetic fields above the solar surface. We can call it a surface for this. And after a while, they'll either rain back down or they'll snap. And then when they snap, they fly off into space. Um, and the rumor is this guy up here is just out of frame. I can actually kind of scoot up there for a second if you want to see him. This guy has been here for several days, and he might fly off. And when he does, it'll be very cool. We can watch it. It'll be cool because I've actually never seen one fly off from this perspective. Usually, when I see them fly off, they're from the limb. But we'll see it flying towards us, basically. So we'll see the kill shot heading for Earth. Don't worry, not actually a kill shot. It won't actually hurt us. If you ever read anybody saying that a solar flare is going to like kill us, just assume that they don't know what they're talking about because they do not. They're probably just trying to get you to click on their video. I love how these things get all squiggly. So you can really see the magnetic field here. Let me zoom in a little bit more so you guys can see it better. Maybe I'll increase the contrast too. So what you're seeing here is kind of like iron filings on a magnet. How these things curve around. Let's actually get this a little bit darker. There we go. There we go. All right. So, just kind of visualize holding a magnet up to iron filings and how they form around the poles and everything. But that's basically what you're seeing here. You're seeing the shape of the magnetic field uh, becoming visible because of the plasma of the sun. It's plasma is very easily manipulated by a magnetic field, and it kind of adheres to those magnetic field lines. But that's what you're able to see, in real time with this. It's funny. You hear scientists talk about, oh, the magnetic field of the sun, this, that, and you kind of think to yourself, well, I'm never going to be able to see that. But it's like literally using my amateur equipment, I can see the magnetic field on the sun, which is crazy to me. The magnetic field is literally an invisible thing, and I'm able to see it with my own equipment. But it's kind of neat being able to personally validate the things that I've read about when I was a kid. But love, like, when you really look in here close, you see these little tangled knots of plasma. By the way, guys, if you want an existential crisis, Earth would probably fit in that little triangle right there. Like Earth would like dunk in that. So that is how big this area is. I mean, the whole active region is probably bigger than Jupiter, but yeah, Earth would fit like right there. Just to give you a bit of an existential crisis, and yeah, the sun's big. I mean, it has to be, otherwise I wouldn't be able to zoom in like this. But yeah, very, very large. God, it does look like it's getting brighter, doesn't it? I mean, kind of, right? Looks like brighter than it was earlier right here. Maybe it will pop, maybe it won't. We'll see. Oh, somebody called out my FPS. So if you're looking down there at the bottom, you see 25 frames per second or whatever. So these astronomy cameras can actually have very high FPS. They can shoot at, hundreds and, beyond frames per second, depending on how high your field of view is. That's specifically why I use these cameras, is for their high frame rate. However, when I'm doing a time lapse like I am right now, I don't want a high frame rate because then I end up getting my memory card would have been filled up way earlier. I don't need the highest frame rate, so I actually intentionally throttle it. I'm going to really quick just check my memory if you're wondering what I'm doing. Oh, we're still good on memory. But by throttling the frame rate, I'm able to get this time lapse shooting it for hours, hours and hours. So, because either way, the time lapse super sped up anyway. It looks pretty slow in real time. Well, sometimes I feel like I have imposter syndrome when I talk with you guys, mainly because I don't have any formal education on this. Everything I've learned, I've just kind of gleaned throughout my years of shooting, and by talking with peers. And I have some incredibly smart friends that have a lot of knowledge on this stuff. A lot of them are PhDs in astrophysics, so I do feel like I know what I'm talking about for a lot of stuff. But there's always stuff I'm missing. So if you're an expert on a topic and you ever hear me get something wrong, please, I have no ego about this. Like, feel free to chime in and tell me what I got wrong, and I'll listen, because I definitely don't ever want to spread misinformation or anything like that. And I want to be, very open and honest that I don't always know what I'm talking about. I know what I'm talking about with a lot of stuff, but not everything. I find that when you do this like I have for a while, what you end up with is a very broad spectrum of knowledge that does not go very deep. Like, I know a little bit about the sun, a little bit about the moon, a little bit about galaxies and nebulas and planets, but I don't know any specific one thing backwards and forwards. And that's, to my detriment in some ways. But in my opinion, what the knowledge that I have now actually serves me very well because I can kind of comfortably talk about all these topics. Um, but as far as going like really, really deep down the, the rabbit hole of solar physics, nah, you want to talk to an astrophysicist about that. But I can answer obviously the high level questions. And if you're really interested, I encourage you to just learn about it on your own. Yes, yes, jack of all trades, master of none. No, I'm a master of moon photography. That's what I'm the master of. uh, I'm not really the master of moon photography, frankly, because there's other people out there that shoot it much better than I do. I like to think it's because of my conditions, but honestly, I've got such talented peers that um, I think where my strength is actually is just reaching the biggest number of people. I think I'm just a little bit better at self promotion than the average astronomer, which is why I get the audience I do, and I'm able to reach so many people. I don't think it's particularly because I have any special skills beyond that. Um, I mean, my superpower is just being endlessly fascinated by space. I don't understand why everybody's not endlessly fascinated by space, though. Like, space is crazy. Like, there's nothing like this on Earth that we can compare this to. It's so otherworldly, and the fact that I'm able to just sit here and watch it is crazy to me. Sun TV. Oh, it's funny. Somebody calls me out. They say, "Hey, you said you're still good on memory, but when your bars was red because it was so full." That is true, but I live in the red. I That is where I live. Is like in that extra 10% of drive space. So yeah, that is plenty of memory for me. Yeah, it's kind of depressing. I see this comment here. Back in the 60s and 70s, all the kids were into space, but not anymore. So obviously, space was a big thing in the 60s and 70s because of the Apollo program. And I know somebody's going to say something about this, but we got people to the moon. We were able to dump, what is it, 2.5% of our entire federal budget, of America's federal budget. Global superpower America took 2.5% of its net worth and dumped it into getting people to the moon. God, if we did that today, it would be crazy. Um, and unfortunately, yeah, we've kind of lost touch, I think, with that because there was such this glorification of space exploration at the time because it was something so unattainable, and now it's just kind of become a memory, to the point where you have new generations, the youngest generation, Gen Z, like more than 50% of them do not think we went to the moon because they're that disassociated with that. And it doesn't help that they're getting education on TikTok. Sorry, no offense, Gen Zers. There's plenty of you that are very smart, very awesome. Don't If that's not you, then sorry, don't take offense. But um, it's unfortunate that that's where a lot of people are kind of learning things. They're learning it from social media. They're learning it from places that aren't going to give them. First of all, they don't have the best intentions. So and then of course they're just not giving good information. Yeah, we went to the moon. I know we went to the moon. My grandpa worked on the Apollo mission. He was ground support. Best man I've ever known, and I trust him implicitly. And he worked very closely with Apollo astronauts. So yeah, we went to the moon, and I have a very strong bias there, which I'll admit. But if you ever have any questions about the lunar programs, I'd love to talk about them. But we're going to be going back to the moon soon. Artemis 1 was a huge success. Artemis 2 is potentially going to launch here early next year, and that's going to take astronauts into lunar orbit. They're going to be on a free return trajectory, so they'll go loop around the moon and then come back. And then Artemis 3, we should be landing on the moon as long as the landers get developed and improved. So yeah, we've got another lunar program in the works that hopefully will excite new people like the Apollo program did in the 60s and 70s. Hey, Mikey, feel free to DM me about your sharp cap struggles. I'm not gonna like sit here and get into the weeds on troubleshooting your astrocam on a live, but I'm happy to answer questions via DM. These things are tricky, and sometimes there's just little quirks to them you have to work through. Oh yeah, looking pretty consistent. It hasn't really flared for me, so that's too bad. It's definitely changing. So, we'll see in this time lapse that I'm shooting that I'll probably post tomorrow. So I'll probably post a time lapse here in the next like 30, 40 minutes too, because I shot one yesterday and I'll be sharing it. So if you see something from me, that wasn't from today's live stream. It was actually from yesterday's live stream. And then I'll share this one probably tomorrow or something. But this is my sixth consecutive day watching this. So I was able to watch how it changes, how the activity changes. Um, One of the reasons I'm doing this is because that allows me to kind of get to know these things intimately in a way where I can start to have an intuition about them. Something I don't really have a strong intuition for is the way these things move and take shape. Um, but that's something I was able to do with Jupiter, for example. I observed Jupiter for 6 weeks straight, where I was photographing it basically every single night, sometimes multiple times a night, and got really nice time lapse of the storms. And what that gave me was an intuition for how the storms move, based on their latitudes on Jupiter, whatever. So now when I see Jupiter, I can kind of visualize what's happening, even in a static photograph. And I really want that for shooting the sun. So, it sometimes just takes putting the time in, but once I've done this enough times, I'll get an intuition for how these things move. And then hopefully that'll allow me to be more proactive if I see something happening that may lead to a flare. I'll be like, "Ooh, hey, I think this is gonna flare. Let's pop on here," and then hopefully it'll flare during my live stream. You guys will catch that. So right now it's still more of an experiment. Like I have no idea if this will flare or not, but hopefully I'll get a stronger intuition for it in the future. Oh, somebody was asking, how long will a flare last? Usually they'll last a few minutes. So what you'll see is you'll see something bright kind of form here. So a flare is like an explosion. So just think of it as just a huge release of energy. Like a lot of people call these prominences flares. They're not. That's not what they are. Prominences are very slow moving and they just kind of hang there like storm clouds. Now, a flare is like something blows up on the sun. And when that happens, you just see this kind of bright flash and it'll be really bright. That brightness will probably last for like 3 to 5 minutes, and then that brightness will kind of expand and fade as it expands, and then you'll see material coming out of it. So you'll see um, like let's say like a big puff of gas kind of like moving away from that flare and expands, just like an explosion would. So that's what you'll see if it does flare during the live stream. I feel like I want to get rid of this crosshair just because I'm not really using it anyway. Let's go invert it again. My camera's actually kind of struggling. It actually might be my computer that's struggling, but you see the way it's buffering frames? It's not a good sign. Yeah, it's going real slow. It's too bad. It's funny because I'm actually supposed to be good on memory. Yeah, 140 gigabytes left. That should be good enough. Yeah, whatever. There we go. All right. By the way, guys, I might be releasing some like really detailed sun photos soon. I've been kind of working through it, but every single morning before I get on these time lapses, I was shooting a full disk photo of the sun. And what I was going to do was I was going to take the best of those and kind of turn it into this like high resolution print. So if you want to support me and my work, buy a print. I'll probably have them available on my website, cosmicbackground.io, at some point. But you should get on my email list if you're not on my email list already, because who knows what will happen to these social media sites. But getting my email list means we can stay in touch forever. Well, I don't know if it's gonna pop, guys, but just having fun hanging out and chatting with you guys anyway. Just a breading with a nice question. Do you think you will ever do a combo photo series, like your best photos of the sun artistically layered over a cool nebula shot, for example? So I don't know if you see behind me here, but wait, I leaned the wrong way. This thing. But I kind of do that every year. I do like my best sun photo, my best moon photo, my best planet photos, my best Milky Way photo, and just kind of all stitch them together in one cool piece of art. But yeah, I try to do that every so often. I have to do it in a way that it's obvious it's art though, because I don't want people to look at it and go, "Wow, the sun, the moon, all lined up for this shot." Like I know it seems obvious, but um, I do my best to just have as much artistic integrity as I can when I release this type of stuff. It's tricky. No, it's not bad if it pops. That was a great question. Nope, it's not bad if it pops. It will not harm us. It will just be interesting to watch. And this one, I think it's close enough to us now where we'll get some. We may get some like aurora activity from it. A question on YouTube. So the sun is actually 8 light minutes away. So everything you're seeing is like depends on how you look at it, but 8 minutes old when this happens when you're watching this in real time. The sun is 93 million miles away, or like I don't remember what it is, like 140 million kilometers. I did that conversion in my head. I probably did it wrong, um, but or 8 light minutes away. So it's far, but not that far. So what you're seeing is fairly close to real time. All right. Well, I'm thinking I'm gonna call it. It's not flaring, and I'm getting kind of hungry. um, but I tell you what, if I see it flaring, I will jump back on the live. But I've got other stuff I got to work on anyway. But this was fun. What do we do? A little over an hour. It's fun hanging out with you guys. You guys ask great questions, and hopefully we were able to show this to some flat Earth people who go, "Wow, maybe the sun is real." Yeah, I really like chatting with you guys. So before I go, why don't I first of all stop this? Gotta wait for it to wrap up what it's doing. So I'm gonna stop the time lapse, and I'm going to slew around the sun, and we'll look for anything else interesting before I go. Man, it's so like glitchy. I think the camera's just really hot, so it's going really slow right now. Come on, boom. All right, there we go. I have to click that button at just the right time, or else it records again. All right, so let's slew around. Let's speed it up a little bit. It's going a little slow. All right, so this is the massive filament I was talking about. So that thing is giant. Oh God, it stretches like all the way across like that, hundreds of thousands of miles long. This is a little baby active region that actually flared this morning. It was a C-class flare this morning. And let's keep going. So here is another active region spawning off this sunspot there. Here's another active. Let's increase the. There we go. So this is a series of sunspots in an active region. What else we got? What else we got? We got some filaments there and prominences. Yep, yep, very nice. Look at all these. They look like trees. So many prominences. It looks like nothing else going on. Yeah, I think the most interesting thing is definitely the sunspot I was looking at. Um, and this is, yeah, look how bright that thing is. And it's probably going to flare at some point. Just unfortunate that doesn't happen while I'm live streaming. I don't think I looked at this limb yet. Let's see if there's anything happening on this limb. Oh, other way. Yeah, we got some more prominences. Nothing too crazy. Yeah. So when this thing flares, it actually does kind of look like this. Like, whoops, I did that wrong. So like how the middle is like kind of blown out, you'll know that it's flaring because it just gets so bright like that. Like so bright you can't even see what's happening. And then it'll be like that for a couple minutes, and then it'll fade. But yeah, that's how they look. All right, well, I guess I'll call it. If there's anything else you guys want me to look at, now's the time to ask before I quit. Yes, the sun is spinning. It just takes 27 days, so it happens very slowly. Yeah, very, very cool that we can see this, you know? Kind of incredible that we have a star just the right distance to be able to study it safely while it keeps us alive. All right, guys. So I'm pretty sure this live stream will be available, like the recording will be available on X indefinitely. I don't think it will be on Instagram, and I don't know about YouTube either, or Facebook for that matter. By the way, guys, I never go on Facebook. It just like automatically posts my stuff there. I don't even look at it. I kind of hate that site. Where I'm the most active is probably X. So if you want to talk to me there, that's where I'll be able to chat with you. If you have any other questions, take them there. Slide into my DMs. Always love chatting. And hopefully, I'll see you on the next stream.